Have you ever wondered why your Mule application suddenly becomes slow when processing large payloads? Or why a DataWeave transformation that works perfectly with a few hundred records starts struggling when the payload grows to thousands or even millions? Is it the Mule runtime, is it the API, or is your infrastructure running out of resources? Well, not always. In many cases, the real bottleneck is the DataWeave transformation itself. The good news is that you don't need to rewrite your entire application. Small changes in the way you write DataWeave can significantly improve execution time, reduce memory consumption, and make your integrations much more scalable. In today's video, I'll share 7 practical DataWeave performance tips that every MuleSoft developer should know. We'll cover how to avoid expensive nested loops that can slow down your transformations, when and how to use streaming to efficiently process large files, best practices for handling large payloads while keeping memory usage under control, and several additional optimization techniques, including choosing the right DataWeave functions and reducing unnecessary data traversals. By the end of this video, you'll have practical techniques that you can immediately apply to build faster, more efficient, and production-ready DataWeave transformations. So, let's get started. Tip 1. Avoid heavy nested loops. Let's begin with one of the most common performance problems: nested loops. Imagine you have 2 collections. One contains customer orders and the other contains payment information. Your goal is to attach each payment to its corresponding order. A common approach is to loop through every order and, inside that loop, filter the payments collection to find the matching payment. The code works correctly, but there's a hidden cost. Every time DataWeave processes one order, it scans the entire payments list again. If you have 3 orders and 3 payments, that's not a problem. But imagine 20,000 orders and 20,000 payments. Now DataWeave performs roughly 400 million comparisons. That's why nested loops become expensive as data grows. Now let's look into a better solution. We're creating the lookup only once. Each order can directly access its payment without repeatedly filtering the collection. The result is significantly better performance, especially when processing thousands of records. Tip 2. Use streaming next. Let's talk about streaming. Streaming is one of the easiest ways to reduce memory usage when processing large files. Without streaming, MuleSoft attempts to load the entire payload into memory before processing it. That may be acceptable for small files, but imagine receiving a 5 GB CSV file. Loading that entire file into memory can quickly exhaust your available resources. Everything is loaded into memory first, which means memory usage grows as the file size increases. With streaming enabled, DataWeave processes one record at a time. It reads a record, transforms it, writes the output, and immediately moves to the next record. Since only a small portion of the file is kept in memory, memory usage remains nearly constant regardless of file size. This approach is especially useful for large CSV files, XML documents, and supported JSON streams. Whenever you're processing large datasets, check whether your connector and format support streaming. In many connectors, enabling streaming is as simple as adding the streaming property. Some readers and writers even stream automatically depending on the payload type. I'll cover each of these options along with connector-specific streaming configurations in a dedicated deep dive video. Tip 3. Avoid multiple passes over data. Now let's look at another common pattern. DataWeave provides functions like filter, map, and order by, making transformations very readable. However, each function typically processes the collection separately. That means the same data may be traversed multiple times. For small datasets, this is perfectly fine, but when processing millions of records, every additional pass increases execution time. Better example, if you're working with extremely large datasets, consider combining operations into a single traversal using functions such as reduce. The code becomes a little more advanced, but you're processing the collection only once. That's often a worthwhile trade-off for batch jobs and high-volume integrations. Before deploying your transformation, ask yourself these questions. Am I repeatedly looping through the same collection? Can I build a lookup map instead? Is streaming available for this payload? Am I processing more data than I actually need? Can I replace a generic function with a more efficient built-in function? And finally, am I creating unnecessary copies of large data sets? Performance optimization doesn't require complicated algorithms. In many cases, it's simply about choosing the right DataWeave function, reducing unnecessary iterations, and making better use of streaming. These small improvements can dramatically reduce execution time and memory usage, especially in enterprise integrations handling millions of records. If you found this video helpful, don't forget to like, subscribe, and follow along with the 30 Days of DataWeave series. I'll see you in the next episode.